In this video, we're going to algebraically determine the vertex and intercepts for a quadratic function, and then we'll use those to sketch its graph. Once we've completed its graph, we'll state the domain and range of this function. The function that we're given here is the function p, where p of x equals x squared minus 2x minus 8. The first thing we're going to do is determine the vertex of this parabola, and we know that the vertex occurs where x equals the opposite of b over 2a. So we'll use x equals the opposite of b over 2a, and for this particular function, our value of b is negative 2, and a is just 1. So the opposite of b will have the opposite of negative 2 in there, and then that'll be divided by 2 times 1. When we simplify that, we'll get 2 over 2, which is simply 1. To find the y value, or the output, we'll evaluate p at 1. So to find y, we're going to take p of 1, and that'll be 1 squared minus 2 times 1 minus 8. Simplifying that, we get 1 minus 2 minus 8, which is negative 9. So we know that the vertex will be the point 1, negative 9. Next, we're going to algebraically determine the vertical intercept. We can see in our final step that we're going to be graphing y equals p of x. So we'll note that our horizontal variable here is x, and the one on our vertical axis is y. So this vertical intercept is going to be the y-intercept, and that occurs where x is 0. So we're going to calculate p of 0, and we'll do that by replacing x with 0. So p of 0 will equal 0 squared minus 2 times 0 minus 8, and we'll see that that equals negative 8. So the point will be 0, negative 8. Next, we'll determine the horizontal intercepts. These are going to be the x-intercepts, since our horizontal variable is x. And those are going to occur where y equals 0 or where p of x equals 0. So we need to solve where x squared minus 2x minus 8 equals 0. The expression x squared minus 2x minus 8 can easily be factored, so we'll use that approach to solve this equation. X squared minus 2x minus 8 we can factor into x minus 4 times x plus 2. Now that we've factored this expression, we can use the zero product principle to solve the equation. So from x minus 4 times x plus 2 equal to 0, we can now write x minus 4 equals 0, or x plus 2 equals 0. Solving that first equation, x minus 4 equals 0, we can add 4 to each side and find that x equals 4. For the second one, x plus 2 equals 0, we can subtract 2 from each side of that equation and find that x equals negative 2. The points then that we'll graph to represent these horizontal intercepts are the points 4, 0 and negative 2, 0. Remember that when we started, we identified that y was 0 here, so we found the x values that corresponded to y equals 0, and we have 2 points then, 4, 0 and negative 2, 0. Now we're ready to sketch this graph. We want to scale and label these axes in a way that all of our key features are going to fit. So our vertex is at the point 1, negative 9. The vertical intercept is the point 0, negative 8. And then the horizontal intercepts, we have 4, 0 and negative 2, 0. The last thing we'll note is that we know this parabola is going to point upward, or open upward, because of that leading coefficient. So we know that the vertex 1, negative 9 will be the lowest point on this graph. So I'm going to draw my axes in, and I'm going to make the horizontal axis pretty near the top of this grid, knowing that I need to hit that point 1, negative 9. So I'll actually draw it on the second one here, and then I will center the vertical axis, and then I'll label those with x and y, and I'll put arrows to show which directions they're going. Now the way that I've drawn them, I'm going to make each unit worth, or each tick mark worth 1 unit, so I'll scale off. At 2 tick marks I'll write a 2 on the x-axis, and at 4 I'll write a 4, and I'll do the same in the negative direction. I'll mark off negative 2 and negative 4. For the y-axis, I'll mark off negative 2, 2 units below that x-axis, and then negative 4, negative 6, and negative 8 I'll mark off. Now we're ready to plot these points. So let's plot the vertex 1, negative 9. So we'll go to where x is 1 and y is negative 9. I'll plot the vertical intercept 0, negative 8. I'll go to where x is 0 and y is negative 8. And then I'll plot the points 4, 0 and negative 2, 0. I have enough to sketch this graph. One other thing that I can do, though, is use the symmetry to note that for 0, negative 8, I also have 2, negative 8. If I go to the other side of that vertex, I can see that the point 2, negative 8 will also be on this graph. So now I have plenty of points, and I'll connect them with a smooth curved line. So starting at the vertex, I'll curve up, and then from the other direction, I'll curve up as well. The last thing that I want to do here is state the domain and range. I can see, based on the arrows at the end and the shape of this graph, that it's defined for all values of x. So the domain, which is the set of all inputs, will be all real numbers here, and I'll write that with the interval from negative infinity to infinity. And again, I write that negative infinity, comma infinity, with open bracket parentheses on the outside. The range I can see, there's this lowest y value, and it's negative 9, which is determined by the vertex. And then I have all y values above that. So I need the range to be all values of y, negative 9 and greater. So I'll write that as the interval negative 9, comma infinity. And on negative 9, I'll put a square bracket to show that I'm including negative 9. And then on infinity, of course, I put an open bracket.